Good afternoon, learners. Good afternoon, matriculants. Good afternoon to the teachers, and good afternoon to everyone who's watching this program as we are broadcasting. I would like to send a very warm word of welcoming. We are welcoming you in this section. Today, matriculants, I believe that you know already what we will be doing. We are doing grade 12 Euclidean geometry. I understand learners is late in the afternoon, and maybe some of you had a very long day. Some of you were writing the examinations, but we really appreciate that you've made it to come to this session. I know the pressure for grade 12 is enormous at this time, but I believe that you have stayed for too long in high school. You started all the way, it's 12 years now. So just hang on there. You cannot give up now. It's only this year. If you're feeling too much of a pressure, just tell yourself it's only this year. I think it would be a good thing that you leave your matric with a good pass and you have passed mathematics with very good grades. Today we are doing Euclidean geometry, as you can see there on the screen. But there's this activity that I would like us to engage on because I want to connect with you. I want to feel you. I want to know how are you feeling about Euclidean geometries. As we did the last time, I would like you to take your phones and go to the internet browser. Then in the internet browser, you can type in the word menti.com. And then once you log in, you will find a window there where it will require you to type in a code or a password. Then you can type in the number there, 135954. Once you do that, it will lead you to the activity that we're going to do for today. At the same time as the learners are doing that activity, I would like the teachers also to indicate to me. I would like at some point to recognize the teachers who are putting the effort. You write the teacher write his or her name, the name of the school, and the province where they are. So at some point, I will look at the WhatsApp messages, and then I can see and recognize those schools and the learners who are with us in this activity. With that being said, let me just go to our activity on Mentimeter and see. Yes. Okay. So we are doing this activity on Mentimeter. Let me just check quickly. There we go. Now we're having this. The two learners are already logged in. They have said they are feeling about. The question is just be honest about your feeling about the topic at hand. Keep on, learners. I want to connect with you as to see how much do you know about the program. I'm seeing now two learners are saying, I like it a lot and doing quite well. That is impressive. These two learners are confirming that they are doing very well. And there's one learner so far who's saying that it's very difficult to understand. We are seeing that learners are keeping on doing the activity. And on WhatsApp, I'm having Mr. or Miss Sintlalo, it's Sintlalo Senior Secondary School. He's saying he's watching, but they didn't give us the province. Buyani Cezula, is Buyani Cezula Secondary School in Steinberg, Eastern Cape. And also I am having here Leiden High in Delft, Mr. Domingo. So you can keep on participating with us, but we have to go back to our topic for today. We can see also on the Mentimeter, the learners are keeping on logging in. At some point, maybe I'm gonna have some time and come back to the Mentimeter and the WhatsApp messages. But for now, let's just get back to our lesson for today, which is Euclidean geometry. With that having been said, learners, there are some things that you have come across as you are doing Euclidean geometry. You've got big words like theorems, converses, corollaries. Sometimes we do come across those words, we don't even know the meaning. I'm going to just give you the little bit of the background or the meaning of those words. For instance, the theorem is made up of small argument called the axiom. So you build an argument, and then the theorem is the conclusion to that argument. And then if you take the reverse of the theorem, then we get what we call the converse of the theorem. Then we have got corollaries. Corollaries are the statement or the results that you get once you prove the theorem or you get the theorem to be correct. Then the corollaries that just come obvious. So in our slide there, we have a definition for an axiom. An axiom is a statement accepted without proof as a basis for argument. So those statements are the ones that we use to build our theorems. So they are accepted without a proof. Secondly, we're having a theorem. A theorem is a statement that can be demonstrated to be true by accepted mathematical operations and argument. The theorems are the one that sometimes you'll see in the examination you are asked to prove. You can demonstrate, you can prove the theorem. Then now if you take the reverse of the theorem, we get what we call the converse. Every time you hear the word the converse, is the reverse of the theorem. What was the condition in the theorem? It becomes a conclusion in the converse. What was the conclusion in the theorem becomes the condition in the converse. So that's how it works. Now we have in corollary, as I have explained it before, it is a statement that follows directly from a theorem. Now, learners, I believe that in grade 9, you have done a lot in proportion and ratios. So we're going to just give a background because this information is going to assist us, especially that today we'll be doing proportionality theorem and similarity theorem, which is grade 12 geometry. Now, in grade 9, you learn that in proportions, two variables are proportional if there is a constant ratio between them. And then the ratios describes the relationship between two quantities in the same unit. So the quantities must be in the same unit. You cannot compare minutes and hours. You must convert maybe the hours to minutes in order for you to do the ratios. Now, that is very important, learners. If two or more ratios are equal to each other, then we say that they are in the same proportion. For an example, we're having these two ratios or two fractions, AB. We're having these two fractions there. Let me have my laser. AB over CD equals to 5 over 10. So if you know how to simplify fraction, which simplifies to a half. Again, we're having another one there, KL over MN, which is 4 over 8. Simplifying it, we get a half. If you see these fractions, they are different, but they simplify to the same thing, half. So now we can say, in fact, AB over CD is equals to KL over KN. Now, so these ratios are in proportion, or we can say that they are equivalent. We can dig more on equivalent fraction or equivalent or equivalent ratios. For instance, now, taking that AB over CD equals to KL over MN, we replace AB with A and CD with B and so on. Now, these can be true. We have learned this in numbers, in fractions. We have done a lot in fractions. Now, if we are inverting this fraction, we start now B over A. As you can see there, is going to be the same as D over C. But you have to invert both in order for that to be true. Again, what you can do there, we can see that A over B, A over C, you can take this, A over C equals to B over D. Again, this will be true if you are doing D over C, D over B equals to C over A. That also can hold. Now, if we cross multiply, that's what we have. If we can cross multiply here, A times D, which is AD, and then B times C, which is BC. the other thing that you can do here, you can make each one of these the subject of the formula by dividing. For instance, if you want to make A the subject of the formula, you can divide by D on both sides, because what you do on the left-hand side, you do the same on the right-hand side. That's what you can get. A could be expressed as BC over D. Same applies with B, and the same thing that you can do with C. For C, you just divide on both sides by B, and then you get C. And D as well, by dividing by A on both sides, you get D. Now, learners, as we have discussed these ratios and how they are intertwined, how would you manipulate or play around them, now I think we are ready to start the first theorem for today. I believe that you have done the theorem already. We are just now doing the revision and also highlighting the things that are important for you for the exams. So we are doing theorem 1, which is the proportionality. What is this theorem saying? It says that a line drawn parallel to one side of a triangle cuts the other two sides as to divide them in the same proportion. That's what this theorem says. So learners, I advised when I was doing the geometry with the grade 11 that it is important to know also the proper wording of the theorem, because at some time you might be given a theorem and then there will be missing word inside the theorem where you will have to fill in those words. So just make sure that you know the basics of the theorem. So what happens in here, but we have also to discuss the shorter version of this theorem, the one that we use when we are doing our calculation. The short version of this theorem, you can write any of those two: line parallel to one side of a triangle, or you write proportionality theorem, but you don't write that proportionality in full. That AB there parallel to CD is not going to be in every case. It's just an example, but you'll be stating the lines that are parallel. Now, what is this theorem saying, learners? If you're having a triangle and then you draw a line that is parallel to the third side, there's something that happens. What happens? Then we have that condition there, that line DE, you can see there DE is parallel to BC. Now what is going to happen, learners? What is going to happen is AD over DB, we can write that as a fraction, as you can see it there, is going to be equals to AE over EC. That's correct. So that is our theorem there. That theorem is stating that if that line is parallel to the third side, then it divides or it cuts these two sides as to make sure that these two sides are in the ratios of these two sides are in the same proportion. So you must remember that. This theorem, grade 12, is highly its proof is highly examinable. Don't go to any examination without knowing the proof for this theorem. Now, there are things that we can learn since this now is true, that AD over DB is equals to AE over EC. There are other things that we can learn from this theorem, then we call them corollaries. Now, our corollaries, also what we can learn from this theorem is that AB, now instead of saying AD, AB over AD is the same as AC over AE. What you must remember, learners, you don't mix these. If you started by saying AB over AD, you cannot say now on this side AE over AC. So it must follow. If you say AB on this side also, it must be AC. You must remember that. So that is also true. AB over AD is equals to AC over AE. Again, learners, if you're doing AB over DB this time, is the same as, I'm waiting for you to finish. Yes, is equals to AC over EC. Then we can write that down there. There are also other combinations that are also true. It is also true that DB, where is DB? DB over DA, if you take this one now over this one, is going to be the same as CE over EA. That is also true. Same applies when we're taking DB, BD over BA, that one there is equals to CE over CA. So those are also true in the event that the theorem is true. Now we can test our knowledge by doing this example to check how much do we understand this theorem we have just discussed. Now in the example that you see there on the screen, it reads as follows. In the diagram below, triangle ABC has D on AB and E on AC, such that DE is parallel to BC. Now you are given also the information there. You need to check all that information if it checks with your sketch, because I said earlier that sometimes the examiners will trick the learners by putting information there that is not reflected on the sketch. So you need to check if everything that is in the information is there in the sketch. But on this one, without waste of time, everything checks out. So learners, we can begin. Now what is the question? Determine the value of x. We have to determine the value of x here. So I'm having the sketch in front of me. We can begin to do this exercise, learners. I believe that you are excited to do. How do we begin now? Now we're having a triangle here, and we're having a line that is parallel to one line in the triangle, and then we can apply the theorem. What the theorem is saying, this line divides these sides AB and AC in the same proportion. Meaning now we can say, learners, AB, AD over DB. Yes, learners, you need to do this before I do it so that you can test yourself while I'm doing the calculations. Now is equals to AE over EC. That's correct. Now we need to qualify the answer, because whenever you are doing geometry, you need to qualify the answer. How do we qualify the answer, learners? Remember, we have got that short version of qualifying the answer. We're not going to say the whole statement of the theorem. Then we can say line parallel to one side of a triangle. Other learners, they are comfortable, instead of writing line parallel to one side of a triangle, they are comfortable to just write the other one, proportionality theorem. But in this one, you need to state the lines that are parallel. So there, you will write D, since DE is parallel to BC. That's what you will write, and then you close. Either of the two is correct. Now let's do this. Let's quickly do the substitution. Now AD is X, and then DB is 2 equals AE is X plus 2 over EC, which is 3. Now, doing the cross multiplication here, it is easy to see that we're having 3x. X times 3 is 3x equals 2. Now, we multiply these 2, we'll be having 2 into x plus 2. Is that correct? Yes. Now, we can take out the bracket there. We're having 3x equals 2x plus 4. Taking the 2x to the other side, we know it's going to change the sign, and then we'll be having x equals 4. That would be the answer. That means the x in there, the unknown there is 4. So that is just a simple application of the proportionality theorem. And we can move on and consider the converse of this theorem, which is also important. So we know that the converse, we do the reverse of the theorem. What is the converse saying? If a line divides two sides of a triangle in the same proportion, then the line is parallel to the third side. Now, this is the kind of, before we go to the sketch, the short version of this theorem, you can just write that instead of the full theorem. Line divides two sides of a triangle in proportion. This theorem is very important because it gives us another way of proving a parallel line. You know, sometimes that when you have to prove that lines are parallel, you use the alternate angles, the co-interior angles or the corresponding angles. But now, if you can prove that the sides are in the same proportion, then those two lines has to be parallel. So if you're having a triangle in like this, you have got a line DE, then if you happen to show that AD over DB is the same as AE over EC, then you can conclude to say DE is parallel to BC. That is the converse. Now we can also just try this little example here just to have a feeling of how the converse is applied. Now in this example is in your book on page 17. It says in the diagram, KB is equals to 7 units, AK is equals to 42 units, AM and so on, but all of that information is there in the sketch. And I don't want us to waste too much of time, but don't do that when you are writing the exam. Make sure, I know that there's a pressure when you are writing the exams, but make sure that you go through each of this information that is there, checking that what is in the information, is it there in the sketch. What are they asking us here? They say prove that KM is parallel to BC. Here is KM here. We have to prove that this line is parallel to this line in this triangle BC. So let's begin the calculations. I'm having my sketch in front of me. What we need to do here is just to show that the sides are in the same proportion, meaning we have to do AK over KB, and we have to show that AK over KB is the same as AM over AMC. If that is true for both sides, then we'll conclude to say these two lines are parallel. Let's do the calculations, learners. So we're having AK over KB let's do that one. What we get there is 42 over 7, and 42 goes to 7 goes to 42 how many times? Yes, 6 times. Now also we do AM over MC. Now AM is 54 and MC is 9. 9 goes to 54 how many times, learners? Again, it goes there 6 times. We can see that these two ratios are equal. So we can say here AK over KB is equals to AM over MC. What conclusion that we have to do now? We can say that this line divides these sides in the same proportion. We can say then, therefore, line KM is parallel to line BC. But we need to qualify this answer. How do we qualify the answer? We use that short version in the theorem. Line divides two sides of a triangle in proportion. That's what you write there. Line divides two sides of a triangle in proportion. That's how you qualify this answer there. So that would be answering, or we're now having the feeling of how do you apply the converse of the proportionality theorem. Now, after we have done the proportionality theorem, there is a special case of the proportionality theorem, which is called the midpoint theorem. I believe that you have done or you have come across the midpoint theorem in grade 10. It's the theorem that is done in grade 10 and is very exciting. My learners used to be very excited to prove the midpoint theorem in grade 10. But we're not going to dwell much on it. We're going to just mention it so that you may remember that in grade 12 also it is highly applied. Now, the midpoint theorem says that the line joining the midpoints of two sides of a triangle is parallel to the third side and equals to half the length of the third side. When you have to use it in your calculation, you can just write that short version of it, midpoint theorem. Now, what is the essence of this theorem? You can see that we have this triangle there. We have got AD being equals to BD, and AE equals to EC. Now you're having a line that joins these midpoints. There are two things that happens, learners. What are those two things? First of all, this line is parallel to this line. That's what this theorem is saying. Secondly, this line is half the length of BC. DE is half the length of BC. That's what the midpoint theorem is saying. It has got its converse. Its converse also comes in very handy. So the converse of the midpoint theorem goes as follows. The line from the midpoint of one side of a triangle parallel to another side bisects the third side and is equal to half the length of the side it is parallel to. So this is the sketch that is illustrating this. So you can see that we're having this triangle, then we're having these two parts being equal, meaning D is the midpoint. You're having a line drawn parallel to this line. Now what the converse is saying, this line, it divides this side equally. That means AE, it bisects this side. That means AE is equal to EC. Secondly, this line is half the length of this one. That's what it says. Now we can go to the, now we are taking the information that we can go to the similarity theorem. First of all, I think you have learned in grade 8 and in grade 9 similarity and congruence. Let's just collect that information to make ourselves ready for the theorem of similarity. Two polygons with the same number of sides are similar if the first thing, all pairs of corresponding angles are equal, and or number two, all pairs of corresponding the first one, all pairs of corresponding angles are equal, or the other way of showing it, all pairs of corresponding sides are in proportion. Then you can say that those geometrical or those polygons are similar. But now for us at school, we're not looking at all polygons. We narrow our attention to triangles. Now in triangles, we use that short version, AAA, or you can write sides in proportion. Now, it is also important, learners, to know this. When all the corresponding angles of two triangles are equal, we say that the two triangles are equiangulars. That's the word that we use. Every time you see, whenever you see this word equiangular, it simply means that the corresponding angles of those two triangles are all equal. And then congruency, we have got that inscription to describe congruency. Two geometrical shapes are congruent if they coincide with each other when they are superimposed. But then in triangles, we use those four conditions. I believe that you are familiar with these conditions. Side, 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 included angle, and a side is very important. This one, to follow this order, side, included angle, and a side is angle, angle, side. Then this is not right-hand side. It's right angle, hypotenuse, and a side. Now, with that being said, I believe that we are in the better position to do the similarity theorem. What is it is saying, the similarity theorem? If two triangles are equiangular, I believe that now you know what equiangular means. If two triangles are equiangular, then the corresponding sides are in proportion. So first of all, learners, we're having triangles that are equiangular. Then now the conclusion is the corresponding sides are in proportion, and therefore the triangles are similar. The short version of this theorem, you can use similar triangles or equiangular triangles. So that's what this theorem is saying there in the sketch. You can see angle Y in this triangle ABC is equal to angle E in the triangle DEF. Same applies, angle A is equal to angle D, angle Z equals to angle C equals to angle F. So these two triangles are equiangular. What is this theorem saying? Then the corresponding sides are in proportion. What does that mean? There is proportionality. That means AB, there's AB, this side AB, over which side corresponds to AB in the other triangle is this side DE. So AB over DE is equal to the other combination, which is BC, and the corresponding side to BC in the other triangle is EF, and so on and so forth. What is important? These triangles need to be equiangular. then once they are equiangular, then the corresponding sides are in proportion. We need to remember that, learners. And also this theorem is highly examinable. Just make sure that you understand, you go through the proof of this theorem, because you could be asked to prove it either in June examinations or in the trial examinations or in the final exams. So that is very important. Now, we're having this little example here that we can quickly do to apply the similarity theorem. In this example, if we look at it there, we are told that in the diagram is AB parallel to DE. Prove that triangle ABC is similar to triangle EDC. So learners, another thing that I need to highlight to you before we can even get deeper into the application of this theory of the similarity theorem, this symbol here is very sometimes confusing. You might forget when you get to the exam. The similarity stands as it is now, but for congruency is doing the other way. So do know the difference between this symbol for similarity and the congruence. So now, with that being said, let's go to our calculations and see how do we prove that these two triangles are similar. So we're having these two triangles that we have to prove here. We're having triangle ABC. Can we highlight them? Because sometimes it assists to have some highlighting, some color in our sketch, so that we can see things even better, the triangles that they are talking about. So we have to prove that these two triangles, A, B, C, and the other one, we give it another color, a different color. These are the two triangles that we are talking about. Now we have to prove that these two triangles are similar. So where do we start? So we have here we are not given the sides. In the case like this, now when we are not given any information about the sides, we are bound to use the angles. We need to show that the corresponding angles of this triangle are equal. So we can start with angle A in this triangle. So we can say here angle A, which angle is equal to angle A? Yes, of course, angle A is the same as angle E, because we have been told that line AB is parallel to line DE. So these two angles now are alternate angles, of course. So we can say angle A is equal to angle E, and then we qualify the answer. We say alternate angles. And then why alternate angles are equal? Because line AB is parallel to line DE. Then we close. We need just one pair. One thing that I think, because I'm in a rush, you need to write first there to give the attention of the marker that now you are focusing on these two triangles. We're supposed to say there in triangle ABC, the ones that we were asked to prove, but don't write similar. In triangle ABC, and you say and triangle, the second one is EDC. So number one, we have shown that the pair of corresponding sides, one pair of corresponding sides are equal. We need one more pair of angles that are equal. In this sketch, we have got many grounds to play with. For instance, you can see that C1 and C2 obviously are equal. They are vertical opposite angles. And you can see that angle B is equal to angle D. They are also alternate angle. We can have more than we want. But when you are proving similarity, it is enough to prove just two pair of corresponding angles, that they are equal. So number two, we can, for argument's sake, take B. Angle B, we know that it is equal to angle D. Yes, of course, is equal to angle D. And then we qualify our answer. We can use the same answer with the same reason, because we use the alternate angles. We say alternate angles, since, again, line AB is parallel to line DE. Now, at this point, learners, the other two, even if you didn't know anything about them, you could conclude to say these two triangles are similar. Why? The last pair becomes obvious that they are equal because you use the sum of the angles of a triangle. So we conclude to say now, therefore, triangle ABC is similar to triangle. But now when you are writing the last triangle, the order is very important. You must follow the same order that you have done on the first triangle. For instance, here in the first triangle, we started with A. If you look at A, it has got that angle that is marked with one tick. And then we go to this second triangle, which angle is marked with one tick is angle E. So we write there E. And then we came to B on the first triangle. There is B with two ticks. In this triangle, we'll take the two ticks, which is angle D. And then lastly, we have C. So triangle ABC is similar to triangle EDC. Now we need to qualify the answer. We say angle, angle, angle. Some learners are comfortable to write angle like this. Is still the same thing. You can use AAA or LLL. Now, there are instances where you don't even write this. When you're not expected to write this, when you had number 3 there, if you have shown the last pair of corresponding angles are equal, you need not to write this. You can just conclude to say these two triangles are similar without having this qualification. Okay, learners, I think I've also indicated to you that the order when writing similar triangles is very important. Why is it so important? For instance, here, if we have to write now to show that the corresponding sides are equal, that means AB over ED is equals to BC over DC equals to AC over EC. Sometimes it becomes very challenging to write that inscription when the corresponding sides are in the same proportion. If you use the version of using the angles, for instance, you can use this angle and the two ticks, and you check the side there that correspond with that. We have got one tick, two ticks. That means the side that correspond with this side in the other triangle is this one, ODE. But now if you have done your job, you've written the angles you've written those triangles in order following the angles. You can get that easily from that order. For instance, if we check here, this is the hint for you. If you have written them in order, you can say AB over ED, the first two letters, AB over ED, as you can see it there, is equals to, you go for the next two letters, BC, there's BC over DC, there's DC. Now the last one, how do you do? You take the first and the last, which is AC over EC. So you get this. So instead of just going there and try to crack your mind looking at which angle is corresponding to which, then you can use that order when you have written your triangles in a nice order. Now we're having the converse of the similarity theorem, which read as follows. If the corresponding sides of two triangles are proportional, then the triangles are equiangular, and therefore the triangles are similar. So that's what the theorem is saying. So the short version of this theorem, sides of triangle in proportion. Now that's the inscription. If you can prove that AB over DE is equals to BC over and so on and so forth, then that's the conclusion that you can do, that all the corresponding angles are equal. So that is the converse of similarity theorem. Let's apply this converse in this example. In the diagram is PR equals to 15, and all that information is there in the sketch. But what are we asked to do? Prove that triangle XYZ, there's triangle XYZ, is similar to triangle PQR. and that angle Q is equals to angle Y. Angle Q equals to angle Y. There are two things here that we need to do. We need to first to prove that these two triangles are similar. How are we going to achieve that? Now, we're not going to achieve by looking at corresponding angles. We're going to look at that by looking at the corresponding sides, because we're given the information about the sides. Let's do that, learners. So now, with my sketch here, we can see that we can use the corresponding sides. We can guess them by the length. The longest one to be the corresponding, and so on, and off we go. So in this triangle, we can say PQ, we need to show that PQ over the corresponding side with PQ on this triangle, it should be YX. So let's see what we get there. It's going to be 10 over 6. 10 over 6 is the same as 5 over 3. Now we go to the other side, which is QR over the corresponding sides with QR in the smaller triangle. It should be YZ, which is 20 over 12. Again, 4 goes to 20, 5 times, 4 goes to 12, 3 times. Now we can again do the last pair, PR, which correspond with XZ. Now PR is 15 over 9. 3 goes to 15, 5 times, 3 goes to 9, 3 times. You can see all these ratios are giving the same thing. We have proved now that here PQ over YX is equals to QR over YZ equals to PR over XZ. Once we have these, learners, then we can conclude to say triangle PQR is similar, or we can use the one that they have stated there in the information. Triangle XYZ is similar to triangle. Let's check the angles. So we started with X, so it should be P, and then we came to Y. So Y is this angle there. It should be Q, and then we conclude to say angle PQR. Then we need to qualify the answer. How do we qualify the answer, learners? We say sides of a triangle in proportion. So that's how we apply the converse of the similarity theorem. Learners, let's just do one, or I think we will only be able to do one more example, whereby now we're looking at more advanced question. Let's look at this question. In the diagram below, triangle PQR has T and S on QR and Y on QP, such that TY is parallel to SP and SY is parallel to PR. If QT over TS is equals to 9 over 6, determine the ratio of TS over SR. So learners, in this one, all the information is there. We can see in the sketch that we're having these lines. It's very important to know the lines that are parallel. This line is parallel to this one, and this line is parallel to this one. We have got a lot of triangles. We have got a lot of information that we can play around with here. But what is important there, we're given a ratio. Our ratio that is given there is QT to TS, because you can write it that way as well, is equals to 9 is to 6. That's our ratio there. Writing this down in our sketch, we're having QT, which is its ratio is 9, but we cannot write 9 there because that 9 is a factor. So we can write 9K or 9 anything, 9R, it depends on you what you want. And then TS is 6, then we can write 6K there. Now the question was to determine TS over SR. Where is TS? TS over SR. If you look at TS over SR is not in any triangle. That means the only thing that we need to find here is this line, is this part of the line SR. But where is SR? Fortunately, we have the bigger triangle here that contains SR and they are parallel lines. So we can use, we can first find this side, the ratio on this side, and then use the bigger triangle. Let's use this smaller triangle to find the ratio of these two sides, and then we can use that information to find SR. Now we can go to say Q Y over YB is equals to QT over TS. Then we qualify the answer. How do we qualify the answer? There are those two lines that are parallel in this triangle. We say line parallel to one side of a triangle. Which triangle is that? It's triangle QPS. Triangle PQQPS. Now, once we have that, we know that they are giving us the same thing, so which is going to be 9K over 6K according to the theorem, 6K. This factor out to 3 over 2. So the ratio on this side, we're having 3, we can say it's 3R and 2R. That can assist us to find SR by looking now at the bigger triangle. If we're looking at the bigger triangle, we can quickly say SR over this part that we know, which is SQ. SQ should be equals to YP over this part, which is YQ. And then again, we qualify the answer. We can use proportionality theorem. But once we use proportionality theorem, we need to state the lines that are parallel. Since YS is parallel to PR, is parallel to PR. Now, let's go back to our sketch learners. We know the information on this side. Now, this we said this RS over QS should be the same as P Y over YQ. So what is our PY? So it should be equals to 2R over 3R. So this gives us again, I'm running out of time, so let me just start it afresh. So we're looking for SR. Now in this ratio, we're having SR, which is going to be equals to, we multiply on both sides by SQ. So our PY, let's look at our PY. PY is 2R over YQ. YQ is 3R. And then we multiply by QS. QS is the sum of these, which is 15K. Then if we multiply this, this will factor out. And then 3 goes to 15 5 times, and then 5 times 2 is going to be 10K. So we now know that SR is 10K. Now, the ratio that we were asked to find was TS over SR. Now, our TS is 6K learners. We're having 6K over SR. SR is the one that we just calculated, which is 10K. Now K and K factor out, and then we have 6 over 10, which we can simplify to 3 over 5. So that is the ratio for TS over SR. Now learners, with that information, with all the calculations that we've done, and with the time limits that we had, unfortunately, that's all that we could cover for today. I believe that, again, you're going to take this information and the process that I have explained to you. How do you how do you apply this theorem, how to qualify them, because that is very important. Remember, learners, Euclidean geometry is very big in paper 1, and there's also integration of questions that I've seen in a lot of questions. We will see also Euclidean geometry being applied in paper 1. So make sure that you start Euclidean geometry, you get yourself used to it. It's not so difficult. You have just to get yourself used to the theorems. Once you know the theorems, then you go to the exercise. All those theorems will be playing in your head. Apply me, apply me, apply me. But if you don't know the theorems, don't even try to start going to do the exercises, because you will be just confusing yourself. If I can go back and on the WhatsApp messages, I can see that there we have got learners from Nonkobela Senior Secondary at Bizan, and also we having this one is talking about not really understanding Euclidean geometry. Pokazi from Indwe Secondary School, and we have got a lot of interaction on our social media. But unfortunately, we're going to look at that. We will recognize the schools that are participating with that. But because of the time constraints, you can see we're supposed to cover so much of work, and the time is very limited. This is the work that is done normally at school over 4 weeks, but we try to do all of that in an hour. Learners, with all that being said, I think on my side, okay. Before I go, let me just quickly check at the Mentimeter how the learners have said they feel about the program. Let's see there on Mentimeter. We can see that we have got 4 learners. I'm having a less participation today on Mentimeter, but I understand is most learners are writing now already. Some of them are going to prepare for the following day's examination. But 4 learners said they like I like it a lot and doing quite well. That is impressive, and they say it's a higher bar in this activity. And then I'm having 1 learner there. I have a bad attitude towards it, and then there's a 2-2 there in I like it, but I don't know anything. The other one, there are 2 learners that says they are confused, and then there's only 1 who say it's very difficult to understand. So learners, this one who says it's very difficult to understand, it's just that you have to go back to your theorems. Make sure that you study the theorems first before you try to apply. Because if you're going to apply the theorems without feeding yourself with information, then you always going to stack. Okay, with all that being said and done, learners, on my side, I would like to say thank you up until we meet the next time. Thank you.